X-ray photoelectron spectroscopy, XPS, measurements. XPS is a surface-sensitive quantitative spectroscopic technique based on the photoelectric effect that can identify the elements that exist within a material, elemental composition, or are covering its surface, as well as their chemical state, and the overall electronic structure and density of the electronic states in the material. Place surface and screw tight on the stainless steel surface with wearing hand gloves and minimize the dust particles deposition on the surface. After surface fixing on sample holder, then transfer this holder into the pre-chamber of XPS. Place the sample into the pre-chamber and close the door of the pre-chamber. Then wait for 15 to 20 minutes to reach a high vacuum in the pre-chamber. In the pre-chamber, mostly all weak fissizzed materials and solvents are evaporated from these modified surfaces in this high vacuum. Let's see more detailed parts of the XPS instruments. Main chamber, and here vacuum is extremely high, it's also called ultra-high vacuum. The surface is near X-ray tubes and detector. Once the vacuum reaches the green zone, then it allows the opening of the main chamber to transfer surfaces for measurements. Then press V1. This is actual vacuum in main chamber. Transfer rod. This is the pre-chamber view from the top view. Sample movement or operating box. Here you can set the measurement spot and tilt the surface and move both X, Y and Z directions. Also, set the memory position of the sample. Here it's internal optical camera which is focused on sample. This camera you can zoom and also see small dust particles on the surfaces. These cameras help the user find the appropriate points for analysis of specimens. Most XPS instruments include an ion gun that produces monatomic argon ions argon plus for this purpose. A range of beam energies is usually available, typically from a few hundred electron volts up to a few kilo electron volts, allowing operators to choose two etch rates depending on the thickness of the layers to be analyzed. Spectra are collected after each cycle of material removal by ion milling to generate a depth profile, typically displayed as atomic concentration, which shows the variation in the chemistry with depth into the surface. Depths up to a few microns can be investigated using this approach. In XPS instruments, X-rays are generated by bombarding a metallic anode with high-energy electrons. The energy of the emitted X-rays depends on the anode material and beam intensity depends on the electron current striking the anode and its energy. Our instrument has the standard X-ray source which aluminium and magnesium K-alpha radiation sources. These anode materials have very low line width electron volts, to high-resolution XPS spectra. This is XPS detector system. In general, detection limits for XPS range from 0.1 to 1 atomic percent. This XPS has been equipped with a Baltec cryo stage. This means that samples can be introduced and measured under liquid nitrogen temperatures, making it suitable for biosamples and volatile surface species. The light focus on the sample stage in the XPS chamber. The spectra were obtained under ultra-high vacuum UHV conditions using monochromatic aluminium K-alpha X-ray radiation at 12 kV and 20 mA, using an analyzer pass energy of 10 electron volts. Because of the electrostatic charging in the positive direction on the surface, such as glass, a charge compensation was used during the XPS scans with an accelerating voltage of 2.8 electron volts and a filament current of 5.00 ampere. Measurement, spot setting and interest of analysis. XPS spot set high-intensity electron spot by moving X, Y and Z axis in sample movement or operating box. Then set position. Here you can add 100 different spots at a time. After this, select which element you want to analyze. In the current case, we can select wide scan. Here you can analyze how many elements present on the surface. After that, select a single element that is you are interested in to know more details about it, such as oxidation state, binding more and others. Increase number scan to get smooth spectra. Sometimes we use 50 to 200 scan runs to get one spectrum. And it costs almost 1 hour.